Uh, Grade 9, let us look at this problem here. So the question says that we're still on graphs. As you can see, this is a Cartesian plane and then there is a straight line drawn from that grid, right? So they are saying the equation of the straight line drawn below is, so they are looking for what? An equation. When we look at this graph, on the y-axis it cuts at 2. When it cuts at 2, we can write the coordinates there. We don't need to know what is the value of x there. We already know x is 0 everywhere here. So 0 is 2, 2, y is 2, right? It moved 2 units upwards, right? That is our first coordinate. When we look at the x-axis, the graph cuts at -2. So y is 0 everywhere here. As I told you before, this is a line y is equal to 0. This is a line x is equal to 0 because x is 0 everywhere here, y is 0 everywhere here. I'm going to keep repeating this until you understand it. So the coordinate here, x is -2, but y is 0 everywhere here, 0 everywhere there. So this is an x asymptote, not x intercept, this is y intercept. Right, okay, so now the question is, we are looking for the equation, right? And I have indicated before that we use this standard formula to find the equation, mx plus c. You need to know this by heart. You need to know it. Sometimes they're going to give it to you, but you need to know this by heart. Now, I said before, you need to start by finding m. What is m first? Because m, we have an equation. No. Why do I have equation? We have a formula for m. How do we find m? M is equal to horizontal change. Change means what? Change means difference. Vertical change. Vertical change. Right. So, looking at the horizontal change, you need to first find the value of y, the first value of y, and subtract the second value of y. And I have indicated again that we write our coordinates in terms of x and y. So this is a value of x, this is a value of y. This is a value of x, this is a value of y. So when we are talking about y1 and y2, let's say this is y1, this is y2. Alright? Let me say 1, 2. y1, y2. All over, so that things are simple for you. You go to a value of x again for vertical change. x1, the value of x on 1, and the value of x minus the value of x2. From the second coordinate, the first coordinate, the second coordinate. Y value in the first coordinate, the y value in the second coordinate. X value in the first coordinate, x value in the second coordinate. I'm just making things simpler for you. You can do it simple. Say this value minus this one, which is our y values. This value minus that one, which are x values. You can do it that way. But for now, I just want to show you. Practice until this thing is stamped in your mind, right? Then you can do it easily. Say this minus that, and then this minus that. Let us continue. The y value in the first coordinate is 2 minus the y value in the second coordinate is 0 all over. The x value in the first coordinate is -2 minus the x value in the second coordinate is what? What am I doing? Sorry, I made a mistake there. Sorry. The x value in the first coordinate is 0 minus the x value in the second coordinate is -2. So I need to open a bracket and put a -2. I'm sorry for that. Let me go through the x values again. x1, the x value in the first coordinate is this one. X value in the first coordinate is 0, as you can see, minus, open a bracket because there is a -2 in the second coordinate. This is -2. And now what we need to do is to just simplify. 2 minus 0, I'm removing something from nothing. I'm not removing anything at all. Then 0 minus negative times positive is a positive 2. So the answer is what? Is 1. Positive 1. That is what? That is our slope. So m is equal to what? M is equal to 1. Why is it positive again? I'm going to go through that again. When we look at our graph from the left towards the right, it is increasing. Let's say you put a human being here. The human being starts walking towards the right. Along this line, that human being will go up the line. The slope is steep. It is going upwards. So our graph is increasing. That is why we have a positive gradient. The positive what? The positive slope. Right? Please understand that one. If our gradient was negative, that means we've done something wrong here, because our graph is an increasing graph. So the gradient is positive. So we have found m. We still need to find what? We still need to find c. To find c, I have indicated this before, is either you choose the first coordinate or the second coordinate. Now, as you can see, the second coordinate has a negative. We don't want to deal with the negative. We can, for practice, for whatever, I can. But for you, just choose the most simple coordinate here. You can choose any, you'll get the same value. So now, I'm going to choose the first coordinate, right? Which is 0 is to 2, right? So I'm writing my equation here. Y is equal to, I already know that the gradient is 1, so it's x plus c. I'm not writing the 1, it's there though. It's 1x. As you can see, it's only 1x. So we don't write the 1, it's invisible. Even here is 1m, but you don't write the 1, because we already know it's only a single m, a 1m. Once it starts to be 2m, we can specify that it's 2. Please catch that. That's why I'm not writing the 1 here for the gradient, but we already know there is a 1 here. There is a 1 before c, there is a 1 before y. It's invisible, don't write it. Right. Then now, I'm going to use this coordinate. As I've indicated here, this is a value of x, this is a value of y. Wherever I see x, I'm going to put 0. Wherever I see y, I'm going to put 2. So here is y, I'm going to put what? 2. 2 is equal to, wherever I see x, I put what? A 0. 0 plus c. Now you can see it's easier now to find the c, our constant. I'm adding c to nothing. That means c is alone here. There's nothing added, is equal to 2. So our c is equal to 2. We don't transpose 0. You can't transpose something that is not there. It's a 0. Right. Even if it's negative, it's nothing. Right. So we have found our c. Now we can write our equation now that y is equal to, we found our gradient is 1x. For c, we're going to put 2. So it's a positive 2. Positive 2. Do you understand? Don't say x2. Please don't do that. There is a plus here. Put a plus, then put the value of c. If it's a negative, it's going to be negative, whatever value. But for this one, it is a y is equal to x plus 2. Now, again, let me drill this again. Remember from here we found our gradient. Our gradient was y is equal to x plus c, because we found our gradient to be 1. Again, now to find c, I told you before, another method other than just substituting the point, any point here, instead of x and y, you put any point there, right? Any coordinate there, right? You can use the y-intercept here, where the graph cuts at y, on the y-axis, sorry. Where the graph cuts on the y-axis, that is your y-intercept, right? You check the value there. The value there is equal to what? Is equal to 2. That is your c. Remember, constant for a straight line graph is our y-intercept. Is our y-intercept. The constant here, this value here, is equal to the y-intercept. This value where the graph cuts the y-axis, this value 2. So from this step here, you can just say, okay, I already know the value of c. I need not to calculate it. I already know. So you say y is equal to x. To look for c, you just go to the graph, you check where it cuts. At y, you just say positive 2. As you can see, say positive 2. Then you have found your equation easily from there. So the toughest part is finding m. Finding c, if you know your y-intercept, is easy. If you don't know your y-intercept, just choose any point on this graph. We have our 2 points there. You can use any. So please understand the distinction between these two methods. How to find c using a coordinate, how to find c using the y-intercept there, which is 2 for this case. Please, I've been doing this, I'm feeling it now. I've been doing this as many times. I just want you to get it because you'll find these questions on the exam. Thank you so much.